We haven't done CherrySTEM. Yep. All right. Hi. Ha. Welcome to CherrySTEM, everybody. We have sound. And you are here on the CherrySTEM listening to us talk about things as we do.
With our new format where it's surprise, Richard, what we're going to talk about.
Yeah. The new format of I prepare stories and you listen to them. Sometimes you also prepare stories, but I've been taking on the load.
Yeah.
This big, heavy, big
Huge.
load. Huge, such a big load. So CherrySTEM, where we talk about science, technology, engineering, and mathematics, not so much the latter, under a sexy vibe, because cherries and sex and porn stars is who we are and what we do. And I'd really love to make this show into a actual legit podcast, and so we could drone on Spotify and iTunes Play and Google Tunes and all the things. So those who are watching, check out the screen, because I got patreon.com/AnnaCherry on it. And we're 57% to the goal of actually turning this into a podcast and having twice monthly interviews. I have no idea how I'm going to pull that off, but thankfully I know a lot of people. So I'm going to do some sex worker interviews, and I already started this and had some saved up, but then I had a computer wipe, so I have to redo them all over again. But some of those people we don't talk to anymore, so I'm really glad that that I didn't release it. And it was kind of blowing sunshine up the ass to stream it too much, so I want to, like, I don't know, I'm older, I'm wiser, I'm ready to do the podcast, talk about real issues of sex and stuff.
Real issues
on the streets. All right, so we're gonna try not to go over the head of everyone too much. That's
as we used to do.
Right. That's why I prepare stories and surprise them, surprise you with them. That way you don't surprise people with way too much information.
That way I don't make people drink from a fire hose.
Right. As you know, we talked about the big load. I take that to
Okay,
spare
right.
everyone from your fire hose.
Yes. You're constantly taking the fire hose.
That's true. So yeah, we're 57% completed the goal, and that'll be really cool if we reach that. Also, if you all do check out Patreon, do check out the uncommon loot tier, because yes, I did change all of my tiers to Borderlands loot names. There's Bandit, which is the lowest, and then Uncommon, Rare, Epic, Legendary, Iridium.
Nice.
I have an Iridium tier now. I'm so happy. All right, so I would highly recommend checking out the Uncommon tier, because those of you who follow CherrySTEM are uncommon indeed, and you get to hang out with us after the show for an after party where we do more of this bullshit, and you know, even less structured than this. So. Oh, it's not actually showing. Ha! There we go.
What was showing?
The one that's underneath it.
Oh, okay.
It just hasn't updated. But yeah, for those of you who are watching, do check out the screen. So I may entice you with descriptions of my reward tiers and other good Patreon stuff. So enough of all that. I might save that for the middle or for the end in the future, but I made a new graphic, so I wanted to show it off. All right, let's get to the show. Okie doke. So first, it's something really simple, actually. It's not anything scary or big or, you know, what have you. It's really not a big deal. But it's a really fun deal, because we have images from the North Pole of Mars. So yeah, let's look at them. Once again,
cool.
Visual stuff.
Yeah, the North Pole, is that the one that has the water?
Yes.
Because I know there was they recently talked about something going on with water on Mars, and like perhaps like even more indications of life. And I just briefly ran into something like that, and I don't remember what it was.
But the Mars orbiter just sent back an incredible photo of the red planet's icy North Pole. So there's water and ice on Mars. That's cool.
Yeah, well, there's signs of flowing water is some of the interesting things that they've been trying to figure out, if that flowing water is happening now in the present day, or like in small amounts, or is it all just ancient features that are left over. And there's some indications that there's there may be liquid water on Mars, is some of the things that I've been running into.
Well, the climate of Mars is very similar to Earth in the sense that out of all the planets in the solar system, the seasons of Mars most closely resemble the Earth's, even though the Martian year is about twice as long as the Earth's. So the North Pole that they do have these pictures of goes through many changes throughout the season. The region is covered in layers of ice that experience subtle shifts, but then thick layers of water ice cover the region throughout the year. In the winter, when the temperatures drop to extremes of negative 143 Celsius, which is 225 Fahrenheit, carbon dioxides freeze and precipitates out of the thin air, forming a layer of frozen carbon dioxide on top of water ice.
Well, that'd be one way to get the carbon dioxide out of our atmosphere. Just make it...
Send it to Mars?
Yes, send it to Mars. Exactly. And there it'll freeze.
What were you going to say?
And then it'll be easy to collect and send back to Earth. Wait a minute. Yeah, no, I was just saying, and we could just like lower the temperature of the Earth to 200 and something negative. It's not a problem. See, I already got this problem solved.
Yep.
Easy peasy.
Yeah, there's this cool camera called the High Resolution Stereo Camera, HRSC, that is on the Mars orbiter. And the thing is that carbon dioxide can form clouds, and that conceals the ground below from orbital view. But it's a really badass camera, so it's like, I don't give a fuck. I'm gonna take these pictures. That's how the camera do.
That's how the camera do?
The HRSC is a powerful full-color camera that is imaging the entirety of the Martian surface. Overall, it captures images at about 10-meter resolution.
Nice.
So that's some fun, printable resolution.
10 meter. So is that like a pixel, though?
Oh, I don't know. How big is this camera?
What does a 10-meter resolution mean?
Within the HRC, there's another channel called the Super Resolution Camera, SRC. They can capture images at even greater resolution of 2.3 meters / pixel of 2.3 kilometers squared. So 2.3 meters of pixel per pixel.
That's just one pixel.
Yeah,
oh
one
God.
Pixel is
so you can't. Well, okay.
Yeah.
Oh, so 6 feet is a single pixel. That means you can't like. I mean, the stuff like from Google Earth, you can make out like vehicles, tires, and shit from those satellite photos. Why the fuck don't they have resolution that good? That doesn't make any sense. Because if 6 feet, ish is a fucking single pixel, that's trash.
Well, maybe they can't go in that deep.
They can't go in that deep.
Yeah.
I don't know. I don't know.
But yeah, there's the Coriolis Force.
Yeah.
Do you know anything about that? Tell us about it.
It's the reason why
Hurricanes happen, right?
No. It's the reason why hurricanes spin opposite directions depending on the whether they're in the north hemisphere and the southern hemisphere. And it basically has to do with the way in which the rotational effect of the Earth changes the general rotation of the atmosphere. So there's the think of it as like the there's kind of a drag of the Earth on like the surface of the Earth on the atmosphere that's on top of it, and so there's a kind of on one. It's too hard for me to explain the Coriolis Force, but it's basically it ends up with where you've got the rotation of the atmosphere influenced by the rotation of the Earth. But of course, it's different in the north or south poles because there's a kind of a center point around the equator that is going to be different for as you move further and further towards each pole. Because like if you think if the Earth is rotating one direction, then you look at the North Pole, it's going to look like it's rotating one direction, and then you look at the South Pole, and it's going to look like it's rotating the opposite. So like let's see. Rises in the east and sets in the west means that the Earth from the top is spinning counterclockwise. So then, if you look at the Earth from the bottom, that means the pole is spinning clockwise. And so it's just the looking at it. There's a transition from the equator up to one and down to the other, where you have two different types of rotation. And so those two different types of rotation end up changing the rotation of all of the atmosphere in between from the equator to the pole. So that's basically kind of what we're usually talking about whenever. But there's other things that are also there, but that's just the general subject matter of the atmospheric effects of Coriolis Force.
Because I was going to ask, why do we care? But apparently it has to do with the way it affects all the other atmosphere stuff.
Yeah.
On Earth, the Coriolis Force is evident in the formation of hurricanes and other weather phenomena.
Yes, it is.
In this image of Mars, there are a few streaks of clouds on the left of the frame. They're more likely caused by small local storms that are kicking up the dust into the atmosphere, contributing to the erosion of the scarps. Never seen that word before. And slopes, and changing the surface, appearance, and topography. The overall purpose of the HRSC on the Mars Express is to study Mars' surface process over time, including winds and storms and the seasonal changes at the poles. So that's what they're looking at.
Makes sense.
This is really cool looking. Craters and during its time, the spacecraft, the Mars Express spacecraft has been orbiting Mars since 2003. Long time, wow. In that time, it's imagined the entire surface. It's imaged.
It's imagined. So we got satellites out there just imagining surfaces and sending us pictures back of what it imagined.
Yep.
That's science right there.
I mean, how do you know it's not what's happening? To be honest.
To be honest,
we don't know.
There's no human out there
to tell us. In that time, it's imaged the entire surface of Mars at 10 meters a pixel with the HRC and select areas at 2 meters a pixel with SRC. During its time, it's expanded our understanding of how wet and humid ancient Mars was. It's probed the planet's subsurface processes and structures, and of course, given us some great views of the planet's huge volcanoes and craters. Ta-da! It's a crater. And that's for that story. Cool. So, all right. I guess we're gonna save the crisis in physics for last. Save the best for last. Okay. Unfortunately, it's a Guardian article, which I'm not too thrilled about, but we have giant shape-shifting stars spotted near the Milky Way black hole.
Okay.
Objects raise hope of scientists managing to track blobs being swallowed by black holes.
Blobs?
Blobs, but probably bobs, yes.
No,
and Alice's.
I'm just wondering if, yeah, exactly. Alice and Bob. What are they?
A number of bizarre shape-shifting objects have been discovered close to the supermassive black hole at the center of the Milky Way.
Okay.
The blobs, that are thought to be giant stars that spend part of their orbit so close to the black hole that they get stretched out like bubblegum before returning to a compact, roughly spherical form. These objects look like gas and behave like stars, said Andrea Ghez, a professor of astrophysics at the UCLA and co-author of this paper that we're talking about. These observations raise the prospect of being able to track one of the objects as they drift across the point of no return and vanish over the black hole's event horizon into oblivion.
Well, why don't they think it's part of the lensing? Because lensing does that shit. Like, if you go across certain parts of a lens, and you know, there's no reason to think that the gravitational field of the supermassive black hole is a perfectly uniform lens. So even if it's circling, if you expect a perfect uniformity in their shape, that would be ridiculous. So it would make sense that as it's moving through different areas of the lensing effect, that it would be spread out and come back together, and that seems a lot more plausible than a star being spread way the hell out and coming back together and still behaving like a star.
Well, the way they're talking about it is that the first of these unusual objects, which they named G1, the first time they saw it, showed up on astronomical surveys way back in 2005.
Okay.
And they didn't see one and didn't care about it because they hadn't seen one until 2012, where they saw another one very similar, was spotted by German astronomers, and they called it G2. Okay. So it was this sort of like somewhat rare event. So a quote from from the same guy, co-author from UCLA, Gez. We had seen it before, but it didn't look too peculiar until it got close to the black hole and became elongated, and much of its gas was torn apart. It went from being a pretty innocuous object when it was far from the black hole to one that was really stretched out and distorted at its closest approach and lost its outer shell, and now it's getting more compact again. So Gez and her research team believe that G2 is probably the product of a merger of two stars that have been orbiting the black hole in tandem before morphing into an extremely large star cloaked in unusually thick gas and dust. That's a whole lot of unlikely
assumptions. My God, astrophysicists are like the most presumptuous. Whatever the first thing that occurs to them, they just start calculating based on.
But like you said, there are no people out there, so you don't know. You just
but the level of presumption.
I feel like physicists are more presumptuous than astrophysicists because at least in physics you can measure that shit way better than you can.
Astrophysicists and cosmologists are very closely linked, and so those people are like 12.38 picoseconds after the Big Bang. There were this many
stars in these
stop.
Positions.
Just fucking stop. Jesus Christ.
Talk about playing God. I know exactly.
They really go through
the perfect conditions that...
The exact amount of dark energy and dark matter that were present were completely different than they... Oh my God. Please just stop.
So G2, thing that we're talking about here, is in an eccentric orbit around the Milky Way's black hole Sagittarius A, which has a mass equivalent of more than 4 million suns. When it reached its closest approach in 2014, observations revealed its outer shell being stripped off and swept down the cosmic sinkhole. Another co-author from UCLA, Mark Morris, professor of physics and astronomy, said that, quote, when that happens, it might be able to produce an impressive fireworks show since the material eaten by the black hole will heat up and emit copious radiation before it disappears across the event horizon.
See, basically, they don't have anything like medicine, and what I mean is that in the field of medicine, you have these people who are counter-arguing with each other, and there are agencies that are set up to make sure that you're not going to fucking kill somebody with some crazy off-the-wall theory that you just presume is correct and keep making medicines based on it. And then there's the testing of the medicines, whereas we just have none of those fucking controls in cosmology and astrophysics. There's no gatekeeper. There's just a group of people who are all like, yeah, that sounds like a good idea, and you're popular and powerful in this field, so of course I'm going to agree with you. It's like, and then it just continues on from there. There's not anywhere near the amount of skepticism and alternative theory. There's, in things like medicine and biology, you've got competing theories. At least you've got people who are competing. And there's just no. I just don't think there's any competition whatsoever, really. On occasions, there's basically just the in group and the out group, in anything having to do with physics and astronomy, and that's just it. There's just people who are part of the mainstream or aren't, there's not. There's just something missing that allows them to just go on just amazing flights of fancy without any. Real counter argument, without any real. These are the confounding factors. These are the alternatives. These are the they don't have any of that present. There's just we've discovered new blobs that stretch into crazy shapes and then go right back to being the same, and that's a new discovery. Yep, that's it. Nothing to see here. Moving right along. It's like no. There's lots of other possibilities that should be like at least discussed or. In some way or another said this is why we didn't think it was that. I mean, and you just really don't see that a whole lot, which you would think that you would.
Yeah. But I mean, I feel like that's kind of been the whole crisis, really, the true crisis in physics.
That's why there's a crisis in physics. Yeah,
right,
exactly.
yeah,
You mean that's the underlying mechanics that is causal in the current crisis in physics.
Right, yeah. I almost foreshadowed the playing God thing, because there's this element of like science, which was a surprise to me, was that it came from like the church and like the clergy, not necessarily the clergymen of the church, but there were a lot of like people of the church and church-funded science projects that.
Well, like there's a historian. I just was reading an article by about there's a historian from Harvard. His last name is Marin, I think, who wrote a recent book, or at least a.
Can I just finish up?
This is relevant.
Well, just why am I talking about science and church? And it's like that the scientists decided to replace the church. Mm-hmm. Because now we're like, we don't need a religious description of things, we need a scientific description,
and that science is very much based in the beliefs and ideas of people who are extraordinarily religious, and that's part of one of the things that this historian from Harvard is pointing out, that you can't understand the where quantum physics came from without understanding exactly how much mysticism and religion was part of those science, and all the various people, how they were fighting over mystical ideas and religious ideas that were the basis for these physics theories. We think it was all a bunch of rational, mathematical, and that's just bullshit. It's not. They're the metaphysics of it, the description, the motivation, the way that you put the math together, and how you would interpret the evidence was extremely based in mysticism and in religion and fights between those various aspects of superstition too. So you know, it's just people don't realize how much of science. I mean, Newton was an alchemist, and people now talk about like that's just a bad thing. And well,
but all of that seems to be completely stripped from our, like, talk about species
yes.
with amnesia, like in so many ways, even recently.
Yeah, we constantly pretend that science is this pure thing and mathematics is this pure thing, and it's just absurd. It's absolutely fucking absurd. How you apply the math is completely guided by your worldview. And so pretending that math by itself can prove anything is fucking nonsense. And that's been the past half century's belief system that's kind of become this immutable, it's become the way that we've created zealots for science. Mm-hmm. And zealots for science, what I mean is people who believe in science superstitiously. Mm-hmm. It's not because, people don't understand.
It's not because it makes sense to them, it's because that is the new authority truth.
Right, it is because it is authority. It is because they are representing the knowledge system of the authority, and then having that group back them up is a way of, it's the sycophant drive of humanity that makes them be this, you know, zealotous, as well as not just sycophantism, but also that really is, you know, the whole group truth. That's how you check yourself, you know, that your own ideas, since you can't have every experience in the universe, you have to rely on other people's ideas to a certain extent, and the way that we do that is through authority systems. And so that has been done in the past, and that was religion, and now we added some rules and shit to that system and called it science. But the truth of the matter is it still has an enormous human element in it, and part of why science was successful is because we used to really look closely at the human element, and mm-hmm. now we pretend that there isn't one. It's math. There's no human element in math. Bullshit.
I was gonna say that it really seems like a metaphor for when you frequently try to describe to, because it all comes down to education. So when you frequently try to describe to some people who don't get it, that it's like you can't just have a wave without a medium doing the waving. It's kind of like that's a metaphor for math, where it's like you can't just have math by itself. It's describing something. It is interpreting exactly. something.
There is a relationship between the numbers, that which is represented and the representer.
And in the middle is the human element.
Right. And we are the ones deciding what represents what in those numbers. It is not just something, there's not pure truth, you know, in math. And that's such a huge problem. And so that is how we've gotten to this place where you have this this problem of shut up and calculate is what David Merman called it. Is it David? Is his first name? For some reason that sounds right, but he's the one who came up with the whole. He was ridiculing the shut up and calculate parts of quantum physics. So the point that actually came from an earlier point in physics, though, where we started believing in in ideas that no longer had analogies. Okay, so like for instance, how is it that you know that you can actually rely on the equipment that's out there in space? No human being has actually viewed the surface of Mars.
Right.
And it's just some...
Oh, the first thing we just watched that. Somebody could have just made that up. I have no idea.
Yeah, exactly. Well, how do you know?
A machine could have literally imagined
right,
it. It could be,
so how do most people then get rid of that fear or idea?
Well,
or
they
that,
look to see if the institution is accredited, if other people have agreed that it is reliable.
And most importantly, it is the confluence of various similar technologies and things like that, seeing that pictures do certain things. Many different devices which have made pictures actually do represent what they picture properly. And so it's like, how do you know that you could depend on the tool and actually think of that as a real observation of that planet? Because at what point do you know for sure that your tool is accurately picking up what you think it's picking up? Because and this is a real question in science, because when nobody's ever viewed an atom, we see pictures, we see representations that are brought together through all these various processes that we believe accurately are representing what is there, but that's not necessarily true as you get deeper and deeper and deeper into viewing the smallest components of subatomic material, especially. So, there is this, we kind of extend from, okay, if I completely rely on this device, then I can completely rely on this next device. But that's not necessarily true, because there is theory in the way that the devices work. And if the theory is not exactly matching the way that you continue to develop the device, then they can deviate. So the theory and the device can start to deviate in your designs. And so there's these little bifurcation points that happen in the designs of technology. Like for instance, in optics, people who do advanced optics don't actually use all the same theoretical physics that many other physicists do. In other words, there's actually little deviations when it comes to technology design. You find that there are these little subfields. It's like, oh, well, we use this. And then this other subfield, oh, well, we typically use this. And it's actually these little subfields, and we pretend like there's this one monolithic, everybody believes exactly the same thing, and that's just not true. And it's because of these small deviations between the theory that you use to advance a technology and other theories, that those can start to fray at the edges, I guess is the best way to put it. But the most important part here is just to understand we've got this culture of not understanding that the map is not the territory. The map is the map, and there can be the
map is a drawing of the territory.
Right, exactly. There can be a disconnect between the representational language and what you are attempting to represent, and that representational language in math can be perfectly self-consistent, and that perfection of its self-consistency can fool you, and that's called numerology. Numerology is where people
using math
in a way where they think it's representing something in reality, and they see that it comes out in these ways that happen repeatedly, and they obsess over the symmetry and the and the repetition and the internal consistency of the math, and do not understand that it is their problem is that they're attempting to connect it to things that it is not connected to. They have that problem of the map and the territory, where they think that the map and the territory are one thing. That is a superstitious belief system around math. And then that actually exists in modern physics. There is the same
worship of the numbers and their symmetries. And it started with Dirac. He started talking about how it doesn't matter if your math doesn't fit the experiment, just focus on making beautiful math. And there's lots and lots of quotes from Dirac where he was talking about this numerology version of mathematics. Now, you know, modern mathematics is way more complex than older types of numerology, but it has that same appeal. But it's at another layer where you can't, like when you're looking at magic squares and, you know, things like that, you can kind of pretty quickly and easily see, oh yeah, well that's, of course it lines up in this one way. So what? Who cares? But when you have math go down these long lines of computation and come back around to point at the same point where you have this symmetry that's like, whoa, and then you have this wow moment because it's so far away in your thought process from where you started, that when you come back, that's like, wow, that is so awesome. But it's a property of the mechanical nature of the math.
It's a machine.
Like
it's a gear system.
Exactly. Yeah. It's like a system of gears that it has to come back around. Completely predictable. Because it is like a machine.
It is a machine.
And so we can
An equation is a machine.
Absolutely blown away and have that spiritual, superstitious kind of feel about more modern maths, and not realize it's just the new version of numerology. Look at the design of this flagellum. Yeah, it's exactly. It's a new type of numerology, and people don't recognize that. And so because our advanced maths have been used to accurately model real things, and we're very close, it's hard to notice when it starts to deviate, when our ideas start deviating from properly representing reality. And that started really happening with Dirac, where he was like, he didn't give a shit that it doesn't necessarily have any kind of metaphysics that make any sense. And the truth of the matter is, you can continue to put together pieces of technology you do not understand to make something work. A great example of this is when I first, before I did the first line of programming, before I had any training in programming whatsoever, I went into a modded version of Quake, which is the old 3D game, and I went in and I altered some of the shit that was in C code at the time, which I did not know at all. Yeah. I didn't know the slightest fucking thing. I just could look at the symbols and the names and things like that and futz with it. And then I don't know how the fuck I got it to compile, but I've got it to compile, and it worked. And that's the thing, is you can take pieces you do not understand and put them together in a novel way.
Just like, well, or also just like a children with literally a toddler with a smartphone.
Yeah.
Like, they're navigating that crazy shit that, like, senior citizens can't figure out who have way more life experience. So you don't need intelligence to be able to put things together.
So that's what happens, is people, as the theory becomes disconnected from the mathematics, but you can continue to take mathematics that worked, rearrange them, and it be completely based on some crazed bullshit idea that you rearrange them, because you just keep rearranging them until they fit together and actually do work. And it's just the same thing. Like when I was compiling that program, I'm sure it probably failed a few times. I rearranged shit until it compiled. Right. And that's a lot like developing new mathematics in physics, when your theory about what it is that you're doing and what it represents is completely fucking wrong. And so you can continue based on from older mathematics that were strongly, there was a strong representation between them, and end up at a point at which your theory about what you think you're doing with the math and what it's actually doing are completely fucking different. And so that's part of what people don't really understand about having this superstitious ideal around science, and a superstitious ideal around mathematical physics especially. And that's one of the reasons why I find it so important to call out this enormous problem, because it is what's responsible. We have lots of math that does work very, very well, but we just can't extend it anymore because we no longer understand what it is that it's representing. And so there's and that started really, really happening right around quantum physics. I mean, it got really bad. It started in actually in 1905, truthfully, because Einstein was extending Lorentz's theory, and well, he was using Lorentz's kinematics to have his own electrodynamics, and so he just was taking it carte blanche that it was the truth, kind of, taking that as one of his starting axioms. And what Einstein was actually adding was the electrodynamic part based on Lorentz's kinematics. So, but the thing is, he didn't understand what the math of Lorentz's kinematics was representing, which was an optical illusion. Lorentz was representing with the
ether
math
illusion, right?
an optical illusion. Okay, and so because he did not understand what the math represented, he took math that really did work and represent reality, because that's what Lorentz did, is he created math that really worked and really represented reality. But then he took that and eliminated the representational part, the tie between the map and the territory. What is it that made us understand the map and the territory relationship? And he broke it because he didn't care about that part. He even said at the beginning, it was like, you don't even have to get, basically when he was saying he didn't say there is no ether in his 1905 paper. He said you didn't need to consider it, which is why in 1920 he specifically said you absolutely need a fucking ether. Space without ether is unthinkable, is the quote from his Leyden address. But so that was one of the first time in which we started basically running into physics theories where they were starting to break apart accidentally the theory from the mathematics, and so your representational language was losing connection. And so that's just been that is the problem with modern theoretical physics, is this break of connection. That's why we've arrived at this dead end. And so you were going to talk about the dead end. So you want to you can go over that article.
I will, because we're pretty much done with the shape shifting. This is so the bottom line of the stars is sort of kind of, we don't really think they know what they're talking about.
And there was a point I wanted to get at that I kind of may have been derailed a little bit from. And that was basically, so the question is, how is it that you know that a camera is actually
in space?
In space, you know, because of the crossover of lots of different uses of it. And that's kind of what we do with our, before the internet, before we started using authority again so strongly with the internet, which is what we started doing. One of the things that people had to do pre-internet minds had to take information that came in and use a combination of authority sources, which they didn't necessarily have access to the library very well, or and the time required to look things up at the library. So you used a combination of knowing how various things worked from different angles, and saying, okay, I know this works here and this works here and this works here, and so there's an analogy between these things that makes them all lead to the same thing, that this is within the realm of possibility. And usually that was based on some sort of mechanical understanding of the world around you. And so that's kind of the reason why you don't even suspect that what the cameras who are showing this landscape on Mars, you don't even suspect that it's just some dream that's nonsense, because there are cameras that work on basic specific principles, and you've seen enough different versions, different cameras doing the same thing. And so that's why you have to have replications of experiments, because you need to see a lot of people do the same thing in a different way and come to the same effects and conclusions, to be able to know that what they're doing isn't some huge disconnect between their what they're saying they're doing and what's actually happening, so that at least it's replicable. And now I again have to repeat, you can have a superstitious idea of what you're looking at and still repeat the same circumstances, just like that what I always bring up with the beating the root, that's the spirit of the fishing tree into the water, does make the fish rise to the surface. And the fact that you believe it's a spirit instead of a neurotoxin has no impact on the fact that you can replicate your procedures through your story, whatever bullshit story you may have about reality. If you replicate the same set of procedures on reality, even with your crazed idea about it, you'll end up getting the same results. And so there is no way to know if your model is correct. You at least can know if certain steps lead to certain things. So that's why we have these various systems that we used pre-internet to come to the same kinds of conclusions. Hey, so where did you want me to? I can start reading this article. Oh, okay. Well, because I was about to you started leaving just as I was coming to an end of what I was saying. I'm like, I've got less than half a sentence, and you're running away.
Because you that was we weren't quite done with the black hole thing.
Okay, go ahead.
And you already want to go to the next one.
Oh well, you want to finish the black hole thing?
There's just 2 sentences. And if we could have just waited for 2 sentences before going on this tangent, that might have been a better segue. But because I have no faith in ability to hold any context of anyone who listens to us.
Okay, yeah.
In fact, I probably find it they probably find it extremely anxiogenic to not understand what we're talking about within the first 30 seconds of. We never tell them what we're telling them.
Okay.
We only tell them and then tell them what we told them, but we never tell them what we're going to tell them. Like, I have no idea why we start talking about anything. But okay. I also hate to cut off any kind of tangents. So anyway. So yeah, hopefully you guys. You know what? There are viewers out there somewhere who can follow the whole thing and who understand and can have
our viewers are the very best viewers. What are you talking about? I think they get it. It's
even if they don't get it, they're still happy to hang out with us and have it go over their heads a lot.
Well, I think sometimes that's why I like to read things, is because I go back over it a number of times, and so hey, kudos to them if they can follow something that's verbal alone, because I can't. I've got to read it, and every time there's a problem, I go back and read it again. That's why I only really communicate via text instead of verbal communication.
But we listen to TED Talks and stuff. So
on occasion, because that's very, very.
That's what this is supposed to be.
They keep it pretty. No, it's not. I didn't make slides. I didn't. It's like somebody does it. When I do a talk, I do slides and I prepare beforehand.
Well, the point is, we do listen to talks and get information.
And here's the thing: you
from
say,
something like a podcast, you can get information.
Okay, supposedly you're supposed to tell them what you're going to tell them, and then tell them what you told them, right? Okay.
Right, yes.
Well, the problem with that is if you say anything controversial. And you tell them what you're going to tell them. That is a synopsis. That is basically saying beforehand. You set up a person, and when you tell somebody something in short form without a good explanation, something that is unbelievable, they are then primed to disbelieve everything you say from that point forward. That's why you don't start with tell them what you're going to tell them. If you're talking about something controversial, you first tell them.
Well, don't tell them it's controversial. Just
exactly, and then you tell them what you told them, and then they go, oh. Okay, and that's the only way you can bypass the bias filter that is automatically set up by saying something that is unfamiliar to a person in a very short form, which allows them to exhibit extreme doubt, because anything expressed in short form does not have enough supporting information in their head, and I can usually expect that people will not have enough supporting information, so therefore that's why I skip that part a lot of times. So excuse me.
There's this interesting relationship too between people that are more scientific minded, who actually cannot necessarily follow context of things that are in their mind too different or don't relate, versus people that are more liberal arts and compassion studies, whatever it is. I'm one of those people, the humanities, and so then you have those people that are able to. They may not necessarily get the super scientific stuff, but they can at least understand the greater idea that you're representing, because we're talking both at the same time about science as well as humanities, sociology.
The sociology of science is extremely important, and that's what that is the difficulty here, is that I'm talking about science and sociology, and those are two different kinds of things. Because the scientist in me, whenever I'm looking at something new, I go, wait a minute, what is that? What do they mean by this sentence? And I actually do break it down in those tiny parts, sometimes not waiting for a big, longer context to explain what that sentence was. I instead want to verify if what they've said at the smaller level is correct. And the problem with that is that sometimes you will not yet have the information to verify that small
That happens
piece.
to me a lot.
And so you have to have the patience to get all of the other pieces before you can even begin to verify that one piece. And the problem is, a lot of times whenever you hear something that you don't currently know, or at least have information that feels like it would be counter to that, you immediately tend to hang on that when you are a more scientific mind. In other words, you will hang at that point.
And if you're a less scientific mind,
that sounds like bullshit.
And if you are a less scientific mind, you'll give up on it and be like, no, what are you talking about? Tell me what is happening.
Well, then a lot of times there is a patience to hear a bigger picture that will allow.
That's what I meant by like the gender studies or the humanities or whatever, because
that will allow the verification of the smaller parts.
Right. We have the two types of viewers as well. We have the more scientific viewers, and we have the more liberal viewers or liberal arts study majors. And then because we do talk about this confluence of science and humanity, and so we both project the two views. And we have an audience that has those two views, so there's a whole lot of Punnett squares.
So let me add another layer of meta. So now this is a very meta conversation, and by talking, we were talking about what we were talking about, and now we're talking about that.
Okay.
So we just got to the third layer of meta. Okay, I just had to do that because that was fun.
Okay. Are we not going to talk about anything?
What the self-referential? What are you talking about? Because I was just talking about that we were okay. Let's back up a couple layers. We were talking about our show and how we present
right. So we broke down one.
So that was the second layer, right? And then I said this conversation is meta. So I was talking about us talking about ourselves, and so therefore that got to the third layer, right? So that's all. It's just
meta squared.
Right, meta cubed. It's the Metatron. Okay, sorry. We had to have a moment of comedy. Break the.
Yes, we did. No, it's true.
All right.
So the thing where like we basically last we left off, because I was gonna wrap up this article.
Last we left our heroes.
Yes. I was gonna wrap up the article and being just like, yeah, well, they seem like they're full of shit, but because as we're saying, there's no people out there in space. My argument is that they're just trying to come up with a theory as best as they can based on their observations. And so what I wanted to add is that they did have more observations of the same type of stuff, because they, when they were seeing this, one of the co-authors said that, when they saw the shape approach the
event horizon.
Right, the event horizon. I wasn't sure if that was a real term or like a sci-fi term.
No, event horizon is a real term.
So I have too much SG1 too. It's like, wait. So when that happens, it might be able to produce an impressive fireworks show. Oh yeah, I already read that. So at the time, G2, that was the 2015, 14, whatever one. At the time, or 2012, whatever it was. At the time, G2 was thought to be simply a large diffuse cloud of gas. But astronomers were surprised to find that the object survived its close encounter with the black hole, suggesting that it must have a dense star-like interior.
Yeah, that's such a bullshit assumption.
That's why they have all those assumptions. And latest findings based on 13 years of observations by the W.M. Keck Observatory in Hawaii reveals a further 4 objects in similar orbits, all of which are within a few light months of the Milky Way central black hole.
Okay, so that's such a bullshit assumption.
They've
because
seen it
of the
a few
fact
times, and it distorts.
Yeah, and we've seen a
together.
lot of times whenever they used to call it like Einsteinian lensing, or when gravitational lensing occurs, you can have an object that looks like it's split across. It splits, goes over the top and the bottom, and comes back together on the other side of the object, and that can look like an event horizon when it's simply just. The way that optics work, it basically kind of turns the image inside out. There's a point at which like I said, a single object or galaxy or star or whatever, when it passes, when the light passes through an area of gravitational lensing, can literally make it look like it's been split in half and comes back together on the other side. So what makes them? I don't understand how they're not saying. See, if they at least said something about the gravitational lensing effect here, I could. I could be okay with some level of maybe what they're saying has some validity to it, but it's just why they're not even addressing it, and why I'm right now I am assuming that they have not looked into that, because a lot of people would automatically assume, well, they're professionals, of course they've looked
Well,
into
they
it.
might have.
But what I found is a lot of times they don't. I used to think that too. I used to think they're professionals. Of course they would have looked into this and they would have accounted for that. Fuck no. No, they didn't. And the same thing is true, like for instance, of the gravitational redshift. Okay, so the entire rest of the universe is redshifted in an amount that is directly proportional to the distance from us. So in other words, no matter however far you get from us, and this is going to be a perfect segue into what we're going to talk about, and however far you get from us when you look out into the universe, whether it be stars and then further on to galaxies, etc., each of those objects, and usually we're talking about galaxies because that's where it shows the most. Then it seems to be moving away from us at a faster rate because it is redshifted. So there's intergalactic, I guess. But there's redshift of all objects, and that redshift is not very different from one object to the next. Like there's not a bunch of objects moving towards us and a bunch of objects moving away from us. And no, according to our observations, the speed at which an object is moving away from us is directly proportional to how far it is from us. So each object, as it is further away from us, looks like it's moving faster away from us if you believe that the redshift is caused by motion. Because redshift a lot of times is caused by motion. However, one of the first things I looked at was with this is like, well, hold on a minute. Light can be redshifted by interaction with various, substances.
Right.
Now,
gases and such.
Right, with gases. Well, okay. Well, the reason why it's not interaction with gases causing it is because that changes at different frequencies of light as it moves. The shifting effect will be different. So, in other words, that's where you get the a more orange light, for instance, from the sun as it gets near the horizon, or a more reddish light. But it is not this direct moving of the entire spectrum redshifted when it's going through dust and through gases. It is various different frequencies are shifted by different amounts. Okay, great. So that's why it's not specifically dust and gas. However, there's something called the Compton effect, where upon interaction with plasma, the entirety of the spectrum is shifted equally, just like Doppler shift, which is what theoretically is happening, why we believe that the rest of the galaxy is moving away from us faster and faster and faster, depending on its distance, linearly dependent upon its distance from us. And just the fact that it is directly proportional to the distance from us is what makes that so fucking suspect, that you should be like, oh my god, this is the most obvious goddamn thing in the universe. How are you not immediately saying, oh, it's obviously the Compton effect? And because there's just enormous gluts of plasma being blasted out of the sun's ass, just coating up just absolutely everywhere. There's just tons and tons of plasma we are surrounded by, coming away from the sun, and it just, there's plasma all throughout the fucking universe, just tons and tons of free plasma just blowing all over the fucking place in the universe, and they're not believing that that's going to cause a Compton shift. The only argument I have ever seen, and I looked a lot, the only argument I ever saw was based on the fact that the Compton effect at extremely short distances in like magnetic resonance imaging, or in like there's a various different imaging things where if you have the Compton effect, what it'll end up doing is making the image resolution become extremely fuzzy. However, that is only an effect of the immense change of the angle of incidence that occurs at short distances. The light that changes by a large, when the angle of incidence of a scatter effect is changed by any significant amount whatsoever in large distances, it'll miss our planet entirely. We will not see that light that is scattered at angles of incidence that are not directly aimed at our planet. However, those which are scattered, there is scattering that still happens directly in a straight line that occurs as well. Those will not be blurred. So then what you have is that you'll see what would be the effect of the Compton effect, causing all of the redshift in the galaxy. Oh, well, we'd look around and we'd see like, I don't know, a background, radiation, cosmic microwave background is what we'd see from those scatter events that didn't come directly from the stars, but just came from like all over the fucking place. And then we would also see everything redshifted from us directly proportional to the distance from our location, because the amount of the total amount of plasma that the light had to travel through would be linearly dependent. So it's exactly what would happen. And it's like the instead we're going to say that the universe is made up of 80% dark pixie dust bullshit. That is what they've chosen instead, because they're not even looking at the Compton effect.
Right.
And it's just so fucking simple. It's so goddamn simple that you'd think that, like, of course they've looked at that. Of course there's some really big reason why they're not. No, there's not a really good reason why not. There's the sociology around around theoretical science is such a strong effect. The sociology, the people believing in what other people believe and taking the authorities' word for it is such an enormous effect in science that it's mind-boggling that how much that impacts the direction that our
and we're
orthodoxy
talking about between
goes.
Scientists, not
yes,
just
between
people,
scientists.
right.
Exactly. It's they don't consider. In their lack of considering the human element, they are the most strongly exposed and weak to it, because they do not think that there is a human element in their science. They have just a ginormous amount of human error being mixed in, because they're not considering it.
Right.
They're not looking for it. They're not expecting it. They're not believing that it's ever present. That human beings are flawed and will be biased by various experiences and by and they're not even looking at the necessity. It is a goddamn necessity that you rely upon systems of authority for your estimation of truth. You can't do every experiment yourself. You can't go and look directly at Mars and make sure that a camera is actually working the way that it is. And you can always doubt that, well, there was no human being that actually saw that thing on Mars, so therefore I could doubt that anybody's actually seen any of the features of Mars. And you can have infinite doubt. And so, because that infinite doubt is a possibility, you must then have these systems of faith that are based on your cross-referencing other experiences with cameras, for instance. You're cross-referencing those, and then you have this basically a faith that is based on a lot of experience, but it is still in essence a type of faith. It is you're not allowing what you believe to be unreasonable doubts. But the truth of the matter is, sometimes you think unreasonable doubts. You think that there are things that are unreasonable doubts, and they're not unreasonable. You just don't have the information you need to know that those doubts are actually reasonable. And so there's this continuum of faith and doubt in our way of looking at the world around us that is dependent upon having to look at these systems of authority and use them because they are the best that we have. We have these systems but then the problem is, because we rely on them, sometimes we don't want to deal with the fact that they can go terribly, horribly fucking wrong. And that's what's been happening in science, is we're at another point at which we need revolution, and there's tons and tons of people who have a really hard time dealing with the fact that we have failed again. That we've come to another point at which our faith that we refuse to believe was faith. We refuse to say we have all these various faiths and these different theories and things like that that completely color and determine the way that we do experiments. They don't just color our interpretations of previous experiments. They guide the way that we set up experiments from those assumptions. We take assumptions, and then our entire experimental setup is colored by our previous assumptions. And so a lot of times you just get this garbage in, garbage out feedback loop, and that's why the Kuhnian revolution, the Thomas Kuhn's structure of scientific revolutions, was so relevant and will continue to be so relevant. It was a fantastic work that really identified a basic necessity of going back and forth between specialization and generalization and finding a ground truth, exploring around it, and then revolutionizing and starting again from the beginning with the new lessons learned and integrated. And so there is this thing that we have a reliance upon faith, and if we face that, then we can say, of course, we're going to continue to fail. We're going to come to wrong conclusions. We're going to make bad experiments. And that's the thing people also don't get, is that there is such a thing as a bad experiment. There where you can set up the experiment to fool yourself, where you are an illusionist. You are your own illusionist. You make these assumptions, and the way you set it up continues to hide the truth from you, because you're kind of an accidental illusionist. And that does absolutely happen all the time because of the expectations that we have forward. It's like, just like those people in Papua New Guinea with every time they go out there with a root and sing to the tree and all that, it reinforces their belief that there is a spirit in that root that is bringing them fish. It reinforces that idea over and over and over. And they have all this just massive amounts of irrefutable proof on personal experience that the spirit has gone out there and gotten them the fish, because they don't understand it's a neurotoxin, because their theory does have some harmony with with reality. It does have some ability to, because it is a truth within limits. And so we have that happen. So the next time that we set up an experiment, we can end up that those same people can go out there with that root and burn it, and they can end up impacting bees, and then that'll be yet another layer of proof that definitely this is a tree of hunting and fishing or whatever the fuck, and the spirit it's a spirit of blessings of food. And there's ways in which this ends up polluting our systems of knowledge, and understanding that fact and having some view of the sociology and the necessity of faith, and therefore the necessity of coming to the wrong conclusions and being able to back out of those conclusions and say, we did it, and we did it for damn good reason. We came to these conclusions, set our sights on a specific goal and a specific set of theories and ideas to go and test them out, and we had good reason to do that, and now we found them to have failed. But the problem is, we become so attached to them, and they become such a personal thing, where it's like, these are and that really, you can lay that at the feet of the people who are superstitious, who were the
I think you can lay it at the feet of capitalism and careerism, and
well, not just that, but
people tying their whole self-worth.
There's bandwagoneers, okay? So bandwagoneers who believe in things superstitiously, who grab onto whatever the next authority is. They really strongly associate their self-worth with their group. In other words, their power, their authority, their value, all of those things are very strongly associated with their group. And so then when your group is the sciencey people, and that is your group that you associate yourself with, and you are that kind of superstitious believer where you believe things almost entirely because of the group, then you can do things like, you can attack other people with, well, they're crackpots and pseudoscientists, and basically be saying they're heretics, because the way that you believe is just superstitious. It's just a popularity thing, and so a lot of times these people have arrogance by proxy. And what I mean by this is they personally don't believe themselves. They can be ultimately humble, just super ultra humble, about their personal self, and then become a vicious, arrogant douchebag based on their group. In other words, these people a lot of times have no self. They don't value themselves in any way. They're like, oh yeah, I don't know anything but the scientific group, and so they gain this power, this through
version of virtue signaling,
through associating only with the group, and then on behalf of the group, they go out and they attack, and they are skeptics. When in fact they are the very opposite of skeptics. Because a skeptic has to be skeptical of themselves.
They're super fans.
Right, exactly. And so you have this group in science, and that tends to pollute. And then of course there's also just science denial. Science denial is a real problem. It's a real thing. It's a real problem. And then they have to defend themselves. So that strengthens it. And so there's all these human factors that end up strengthening these orthodoxies, where people associate the current, the system is good. That idea of taking a theory that works pretty well and exploring around it and doing your best to flesh it out, because you got to start somewhere and got to push it through to its eventual conclusion. That's a good system. That's necessary. But there has to be a cycle. We have to be okay with the cycle. And when you become attached to that one, because you have to sort of attach to it at first to be able to put in the time to explore it and really flesh it out. But then you become so attached to it as a community because of all these various social factors that it becomes the hardcore orthodoxy. You can't be, you're not in the in group anymore. You're part of the out group. You're part of those crazies who don't believe that, in this version of our religion. You're those crazy people. You're the outside. And so it's that kind of religious zealotry that enters any belief system. And the truth of the matter is that, you can pick any group of people who are a fairly large group sharing similar beliefs, and you'll always have bandwagoneers who make them look bad. Pick any group, and like you want to talk bad about Christians. Well, then you can talk about like the is it the Duggars or the Westboro Baptist, and you can pick any group that you want to, and there's always going to be these bandwagoneers who fuck it all up, and a lot of times they end up becoming the majority, because I think that a larger portion of humanity are bandwagoneers than there are the people who actually create these groups.
You mean followers? Yeah.
Right. So they're the people who just jump on the popularity wagon because that is a kind of basic safety that for a human to be part of a group.
The default group, yeah.
Right. And so I think the larger part of most groups ends up always, anytime a group has been around long enough, the larger portion of that group becomes the dominant portion of, therefore, because they are the larger group, they are the dominant part of every group, ends up being the superstitious followers of it, who are just joining the group. And it's like, okay, so this is our articles of faith, this is our our sets of beliefs, these are our the ways in which we carry out these things, these are our rituals, these are our all of those things. And so that exists in every group, and science is certainly not fucking immune. It's now a very big dominant group. And so therefore, because of its power, it is gathering more and more and more of that kind of superstitious believer to its side, whereas the ones who, as a matter of fact, I haven't read the email from John Bush. Oh my God, God damn it, you tricked me. Right as I was about to read it, you
went to help me instead,
because he actually had something good to say about an article I wrote, which was about him. So let me bring this up, because I haven't even read it yet, but this is just kind of it's part of this whole sociology of science and the revolution that's happening in the background. And that is John Bush at MIT is he is at the forefront of the coming revolution in science that is actually occurring under the surface right now. He is the hydrodynamic quantum, is it hydrodynamic quantum analogs or quantum hydrodynamic analogs? I'm not sure, but it's the MIT fluid dynamics.
I don't think it matters.
Well, if you want to Google it, it'll come up better one way than the other. But anyway, so he is the one who's been doing a tremendous amount of the.
We'll make sure to link John Bush's MIT lab in the Patreon public post for this.
Yeah. So let me say beforehand, I'm not going to claim to be the perfect purveyor of anybody else's material. However, like I recently wrote an article about how there was an article in Quantum magazine about these experiments doom the alternative to quantum physics. Okay, so first off, that clickbait title, what they were trying to say is this alternative interpretation of quantum physics, not alternative to quantum physics, but an alternative interpretation. In other words, a different, perspective on what it is that we're looking at, what the evidence actually means, a different perspective of the connection between the map and the territory. How accurate is the map to the territory? That question. What they were trying to say is there were some experiments that doomed this alternative viewpoint of pilot wave theory. That was amazing sensationalism.
We talked about it.
From the the grandchild of
Because it literally
the
was.
central figure of the Copenhagen interpretation, which is the one that they're attempting to.
Yeah, we need to explain a little bit more about that.
I am. You're interrupting me so much that making it impossible.
Because we talked about it on CherrySTEM.
Just because we
and
talked
there was,
about it.
Yeah, no, not only did we talk about it, but it was like the next day or like within a very conspicuous
and the
time
people
frame
who are listening may not have heard it.
that it came out, and we talked about that thing again. So apparently
it's a very important world event. What we're talking about
that's what I'm talking about
the
too.
Shifting of the entire world.
Not only did we talk about it beforehand to it, and then primed the world to be like, what is pilot wave? And then this thing came out that is like, fuck pilot wave, and then we talked about that. But you also wrote an article about it, is what you're saying.
Yes. Okay. So now let me finish what I was saying. Yes. When it comes to an absolute revolution in physics, that means an absolute revolution in technology, which means a revolution in energy, which relates to everything from world power to economics to food to you fucking name it. Absolutely everything is dependent upon
super important.
A revolution in physics, and it will absolutely fundamentally change human existence if we have this gigantic revolution, and it's happening. So,
and the revolution's based on the pilot wave theory, which is counter to the Copenhagen interpretation, which is a legacy of Niels Bohr.
Yes, that is Niels Bohr's legacy. His grandson carried out an attempt, a failed attempt to replicate Yves Coude's silicon walker experiments, which the silicon walkers are these droplets that bounce up and down on a liquid. It is a drop of the same liquid bouncing up and down on that liquid because of the wave mechanics, and he attempted to replicate this dual slit experiment that Yves Coude did, and he failed to replicate specifically the dual slit experimental effects. So what this means is that, originally going back to the Coude experiment, he found that these walkers show this macro level, in other words, way above the quantum where all of the crazy magic shit's supposed to be happening. That these droplets bouncing on a bath will exhibit the same effects, that like a droplet goes through these two slits, comes out the other side, and will hit a screen on the other side in a pattern that has interference. And so this shows what we believed was wave particle duality, which means that it was neither a wave or a particle. It's both simultaneously, but not two separate things, only one thing. And there's this kind of fuzzy idea of reality.
It's a man and God at the same time.
Right. Yes. This fuzzy mystics-based version of reality that came in with Niels Bohr and the Copenhagen interpretation, that is held together mainly by this dual slit experiment. And here you have a droplet which has a wave field that interacts with the trajectory of that droplet bouncing on the surface waves, and as well as altering those surface waves. And this complex chaotic interaction creates a chaotic determinism system that results in not just the dual slit experiment with its interesting pattern that comes out, which is an interference pattern, but also just the entire list of all the other weird quantum effects, from tunneling to how particles interact with each other. There's just a huge plethora that are not well represented in short form of all of these quantum effects in these walkers. So this Quanta article, actually even mentioned John Bush and one of his and another fluid dynamics expert from England, and by name, but they go on to really make it seem like this one failed experiment by the Bohr's grandson's team. Actually, it's multiple teams that he coordinated, but is proof that pilot wave doesn't work. Which that's just multiple steps of bullshit. And the biggest one, of course, is it's only the dual slit experiment that they failed to replicate. And it's only they failed to replicate it because one of the papers that Bush put out showed that not only did they, before this article even came out, another paper that they didn't have in this article, I'll admit it was close, and so they may have just missed it instead of just completely, I don't think they were purposefully creating propaganda. I think it's just, internal bias. But there was another set of experiments that showed how you could obliterate the dual slit or replicate it by changing various ways that the setup works. And so they did this huge study of exactly how you put together your dual slit experiment and what features impact and create changes to the dual slit experiment with these walkers. And so not only did they replicate the dual slit experiment, they made it even, many layers of better understanding involved with that experiment with the walkers. And that is completely ignoring all of the other quantum mechanical effects that are replicated by the walkers. So here we have all of these mechanical effects that are entirely deterministic. Okay, and everything that you've heard about physics is, everything's spooky underneath underneath the surface. There's magical connections between things, and nobody knows why, and it's all just random. And there's this randomness is at the heart of the universe, and spooky weirdness is at the heart of the universe. And you never hear the fact that it is replicable. All of those effects are replicable with determinism. It's just you need chaos theory and you need complexity dynamics to understand how these wave systems work together to create these outcomes based on very subtle effects. And so that actually is something that was shown. And so I was just recently I just got an email back from him, so he at least the first line of it I saw in the email, which he at least liked my article. I don't know how well I did according to him, but he at least liked my article where I kind of explicated some of this stuff, because they've done a review of all of the literature and how much there is to learn from these parts of pilot wave theory, and they're finding things like a better understanding. Because here's the thing, actually, John Bush and in particular, he's not using, so mainly pilot wave is attributed to Bohm's resurrection of de Broglie's work, and so Bohm has his own kind of version of de Broglie's wave mechanics, and de Broglie was the inspiration for Schrodinger, by the way. So Schrodinger's first paper, where he created the Schrodinger wave equation, which is the central part of quantum mechanics. That was based on de Broglie's work, and so Bohm and de Broglie, it's called de Broglie-Bohm theory, is an alternate label for pilot wave. But Bohm's work actually has some small differences from de Broglie's work, because de Broglie continued to develop his work, but he didn't have these experiments to refine what he was doing. Bush has actually pushed pilot wave further by taking some of de Broglie's original work and applying it to this new evidence, and we found all of these various effects like entanglement and what looked like spooky action at a distance, and things like non-locality. Non-locality is just a complex effect. It is not you can move something here and a billion miles away something else is impacted but not really, and no information, and all these fuzzy fucking bullshit ideas that people have are actually explicated in the most fine detail and deterministic, real, rational mechanics by Bush, and of course by pilot wave theory. And whenever people are talking about Copenhagen's silly magic bullshit, they are always talking about, well, there's these Bell inequalities, and what you don't find out is John Stuart Bell talked about how Bell inequalities was bullshit because of pilot wave theory, and he actually talked about it numerous times, that he found it so absurd that people were still talking about Bell inequalities years later, and when they shouldn't, when there's something so obviously a better approach. So anyhow, I forget how we got on this tangent, but it's just really important to this revolution in science that's going on right now, and the problem is that people like John Bush are humble. He doesn't even call it his own work. It should be called like neo-pilot wave, because it is actually an advancement of the theory that brings more information to the table, and it's something that he has personally added, well, along with some other, there's a couple of other people who have contributed from Cambridge as well to the advancement of this of pilot wave. But the hydrodynamic alternative has been there all along. It's there in history and nobody talks about it. It's right there and easily tracked down. And hydrodynamics was the way in which we understood reality before Einstein accidentally causing before Einstein's comment that, oh, I don't need to consider the ether to do these mathematics because Lorentz already did it. Before that moment in time, hydrodynamics was what gave birth to all of our advanced mathematics. So all of the mathematics that we use in physics are based on hydrodynamics. Maxwell's equations are entirely a description. When you look at his papers, he's describing hydrodynamics, and those things continued forward. Hydrodynamics was present all throughout the history of physics up into the present day, and so that is what is occurring right now under the surface. A few people know about it, that there is a revolution happening that is the hydrodynamics revolution. I call it the neoclassical revolution of physics, and it's amazing to be here at this moment when things are about to shift immensely. It's about to become this gigantic thing because there's so much work to do in basically looking at all the work that we've done so far, because a hydrodynamic view revolutionizes what we're looking at so much that we have to look at all these advances that we've made along the way and say, okay, this fits with this fits with this. There's all these points at which the analogy between the two has to be fleshed out better. In other words, okay, so we came to these conclusions with these mathematics, and they are true because they are descriptions of experiment, but they're the way that we divided this from this, and all of our dividing points and things like that that's the problem. Our ability to understand what's happening that we're looking at, what the math actually represents, is divided up into pieces that make it really difficult to continue to advance modern theory. However, hydrodynamics will allow us to divide it up in a different way, but that work still has to be done. So this revolution still has a lot of work to do, but at the same time, what the opportunities it has for advancement, for the changes that can happen, is just gigantic. So anyhow, let's continue forward from that perspective of that there's a hydrodynamic revolution. There's all these various things in science that there are these great alternatives for it, and nobody talks enough about the alternatives. Mm-hmm. That the math can stay exactly the fucking same in certain aspects. In other words, that when you tally it up at the end, the math still comes out the same. It's just the point, the touch points at which you look at the math. In other words, calculating from here to here or here to here, the points at which you look at it will change, but the overall, the way it all adds up will stay the same. And it's just by this revolution of interpretation that will have this massive change. And so, experiments are experiments. They're showing something. Something's really happening, and you can describe that something with numbers, and then those numbers are in some way kind of connected directly to reality. But what it means and how you can then apply it to technology, what it means and how that it will evolve in various ways, and what those symmetries mean, that has been the problem. That is where the actual revolution is occurring. So yeah, let's look at the dead end that physics has hit, and how people are continuing to talk about it day after day after day, that physics is at a fucking dead end. And this is the reason it's at a dead end, because it needs this revolution.
Yeah, actually I think it came from the talking about how you think that there'd be certain simple things that the scientific community would just double check on to make sure it's not that. And they don't. But here we go.
Oh, you want to read it? Sure.
You want to read it.
Cool. All right. Let's see. Science news.
Whoa.
Independent journalism since 1921.
Whoa.
When did this article come out? Let's take a look. What is the date of the article? I like to look at the dates of articles. This came out July 30th last year. Okay, cool.
Still not super new, but...
It's not super new, but new enough. I mean, hell. That's not that long ago.
Wait, last year you mean 2019?
2019, yes.
Oh, so 6 months ago.
Yes. Yeah, right. So
So just 6 months ago.
March?
Oh, well.
Or July. Okay, no, July.
Yeah, like 6 months ago.
Yeah, okay, so yeah, not that long.
Not that long ago.
All right.
Not at all.
All right, debate of the universe's expansion rate may unravel physics. Is it a crisis?
Yes.
Yes. Okay, so now one of the things I need to find this. I've got it written down somewhere, and now I can't find where I wrote it down.
Oh.
But there's this explanation of how far off we are in experiment versus our theory, and it's this great thing where you say it's 100 million trillion billion, and you literally.
I remember that, yeah.
And you literally have to say it that way. There's just no good way of saying how bad off we are in our experiment versus theory. And I just love it. It's the greatest thing because it's the hugest, most enormous comical discrepancy in science, and nobody wants to fucking talk about it because
of course
it's
they
just
don't. It's embarrassing.
It's because it's so fucking bad. It's just so bad. So, all right.
Because I mean, we always do this thing where we're like, we are smart now.
Yes, now those people in the past, they were dumb.
Yeah, we're smart.
But we're smart now. We've got it all right now. Okay.
So we don't want to admit it when we're not.
And we'll never get anything wrong ever again. All right, Santa Barbara, California. The word crisis hung in the air from the very beginning of the meeting. In a room just steps from the ocean in Santa Barbara, astronomers and physicists shifted restlessly in their chairs. Sunshine and sea breezes beckoned, but the scientists had cloistered themselves to debate one of the biggest quandaries in physics: how fast the universe is expanding. And of course, I talked about that earlier. Yep, the plasma thing. Yes.
The Compton effect and plasma.
The Compton effect with plasma, right. Estimates based on exploding stars or supernovas has suggested that the universe is growing approximately 10% faster than indicated by light emitted just after the Big Bang about 13.8 billion years ago.
Yes.
Let me stop them right there. Oh, God.
I mean, you don't have to stop them right there.
No, I do.
Okay.
Oh, I goddamn do. The idea that you're seeing light that was emitted by the Big Bang is just the most ginormous leap of absurdity you could possibly imagine. So 13.8 billion years ago, that light never passed by us. It never got absorbed. It's that same light that was 13.8 billion years ago. We're seeing it right now. That is what they're assuming. There's no words. There's just no words. It's so insane. So anyhow, that's one of the assumptions, that the cosmic microwave background is this view of the Big Bang. We're seeing the Big Bang.
They just want to feel special, like vicariously living through.
It's so absurd. So that's what they're talking about there. It's just, that's one of their articles of faith, one of their gigantic, enormous, crazed leaps of faith that they rely on. Like, it's just, oh yeah, everybody knows that. Everybody knows that. Now a measurement based on observations of luminous objects called quasars had pushed the problem beyond a statistical benchmark known as 5 sigma, denoting that the issue was something to take seriously. At the front of the room on July 15, 2 Nobel-winning physics titans debated the appropriate level of alarm. Cosmologist Adam Rees of the Space Telescope Science Institute, I hope I'm pronouncing his name right, in Baltimore, queried theoretical particle physicist David Gross. How would particle physicists refer to a discrepancy this large? If we found something like this, we wouldn't call it a tension or a problem, but rather a crisis, said Gross of the Cabell Institute for Theoretical Physics at the University of California, Santa Barbara. Scientists at the meeting immediately adopted the word crisis to describe the difference in expansion estimates, but not everyone agrees that the problem is real. In physicists' version of a mic drop, a study appeared online that evening challenging the narrative. A new version of the supernova technique found a value of the Hubble constant, of the parameter that quantifies the universe's expansion, that was consistent with the measurements from the early universe. Measurements from the early universe. Let me say that again. measurements from the early universe.
Didn't realize we had
Yeah, I didn't realize we had such accurate, perfect measurements of the early universe.
and instruments
Yeah,
to
it's
measure
just
it back then.
Yeah, the instrumentation, we got that 13.8 billion years ago. We got it perfect, man. We got it. There's no doubt.
We're so awesome.
Do not look at this too closely, but we have got it completely perfect. We can utterly rely on this data 100% because, well, it's observational data. This is empirical science here, people. The data from measurements of the early universe. So, a crisis or not yet. Much is at stake, including scientists' basic understanding of what the universe contains and how it evolves over time. You know, I love the fact that they're not really dealing with certain aspects of the cosmological constant problem. Anyway, so far, a theory known as the standard cosmological model has succeeded in explaining a wide variety of cosmic...
Did you just say that?
What?
Did you just say standard cosmological model?
No, I said cosmological constant problem, which is also known as the vacuum energy catastrophe. So that's it. I prefer the catastrophe because that's what is a better representation of how fucked up it is.
The crisis, yeah.
Yeah, I mean, okay, so remember, we're talking about right now, we're okay with the fact that 95% of the universe is not baryonic matter. It is not the matter that we see. It is not the plasma. It's not the stars. It's not the dark planets that are not lit up. Whenever we say dark matter, we are talking about magic, fairy, juju that you cannot actually detect with any instruments other than you can detect its effects, just like you could detect the effects of little devils with lassos pulling down the apples from trees. You can detect that. They're there by their actions that they take. That's our belief about a huge portion of the universe, dark matter, and then dark energy. And the two of those combined makes it where I believe it's right around 5% of the universe is what we actually see, and the rest of it is this magical fairy dust that we believe in. These two types. There's two types of magical fairy dust, though. Two types. Thank you very much. We know exactly how much of it there is, and we can quantify it exactly. Yes. There's lots of numbers around this. Lots and lots.
Math doesn't lie.
The math doesn't lie. You can't argue with the math. All right. Much is at stake, including science's basic understanding what the universe contains and how it evolves over time. So far, a theory known as the standard cosmological model has succeeded in explaining a wide variety of cosmic observations. But the discrepancy in measurements of the universe's expansion can mean that the model itself needs to be drastically altered. You think? And this is, by the way, this is in addition to the dark matter and energy. Okay? This other problem is in addition to us having 95% magic fairy dust.
Well, they don't see that as a problem.
That's not a problem. Definitely
Right.
not.
They don't see that as a problem.
That's
see it as a problem, but they don't.
That's not a problem at all. What are you talking about? There's numbers around it. It's proof. It's truth. That's all you need. If the impasse can't be explained away by experimental error, says theoretical physicist Vivian Poulin of CNRS and Laboratory Université et Particules de Montpellier in France. I'm sure I butchered the living fuck out of that.
Yeah, you did. I think so.
It would mean that there is really something very important that we do not understand from the very early universe. No, say it ain't so.
Laboratory Universe et Particules de Montpellier.
Yes. If unknown phenomena occurred in the infant cosmos, such as a different type of dark energy or new subatomic particles, that could alter our understanding of how the universe has evolved and possibly bring the two measurements back into agreement. Because, of course, that's what you want to do. Make sure to just keep working towards bringing
back into agreement.
Back into agreement. Work really hard at that because that's the goal, right? Just bringing your preconceived notions back into agreement with each other.
Aligning.
Is the only thing you really need to do. An expanding issue. One technique for measuring the current expansion of the universe is taking a baby picture of the cosmos and extrapolating to the present day.
What?
Wait. This is good.
Wait. You're telling me they don't take the picture of the current cosmos and extrapolate to what it looked like as a baby. They take a picture of a baby cosmos? Where do they get a baby cosmos?
That infant image is the cosmic microwave background.
Wait, no, what?
Light emitted just 380,000 years after the Big Bang. So it's exactly...
Where did they find a cosmic nursery, first of all? Where are they getting these babies?
Well, this is not a light emitted at the Big Bang. This is light emitted 380,000, and of course I'm just rounding. 380,000 years after the Big Bang. Exactly. We know that because
why?
Because you pseudoscientist, you heretic. I mean, yeah. Okay, so to translate that information into an expansion rate of the modern day universe, there go the alarms. That infinite image of the cosmic microwave background, light emitted 380,000 years after the Big Bang. To translate that information into an expansion rate of the modern day universe, scientists use the standard cosmological model to make a prediction. Using that strategy, scientists with the Planck experiment have estimated that the universe is expanding at a rate of 67.4 kilometers per second for each megaparsec, or about 3 million light years of distance between objects. The number leaves little wiggle room for disagreement. Oh God! It's I mean, come on. If you've ever been, here's the thing. If you've ever been in a religious discussion, this is so fucking familiar. This is so goddamn familiar to me. Okay, I came out of a religion where they had these things where they knew for sure, so for sure, that they get mad at each other about these little agreements over things that they had just zero fucking proof of. But they get so mad about the little tiny fucking details of the bullshit that they believed that had no proof at all whatsoever. And that's what's going on here. This is just so fucking familiar. Oh, God. All right, so little wiggle room for disagreement. The experimental error is only 0.5 kilometers per second per megaparsec. It's only that small. That's the error. That's the experimental error right there.
What?
Yeah, I mean that's it. That is impressive. I am so impressed. Let me tell you, massively impressed.
They have such good experimenters.
So such careful experimenters. Let me tell you, they are the mathiest of mathness that ever mathed. But supernova measurements have settled on a larger expansion rate of 74 kilometers per second per megaparsec, with an error of 1.4 kilometers per second per megaparsec. That leaves an inexplicable gap between the two estimates.
Wow.
Now the community has started to take this problem extremely seriously, says cosmologist Daniel Skolnick of Duke University, who works on the supernova project led by Reese called SHOES. It's unlikely that an experimental error in the Planck measurements could explain the discrepancy. The prospect is not a possible route out of our current crisis, said cosmologist Lloyd Knox of the University of California, Davis, meeting. Plus, another technique with its basis in the early universe, the measurement of sound waves known as baryon acoustic oscillations, when combined with other measurements, agrees with the Planck result. So worries have centered on the possibility that the supernova measurements contain unaccounted for systematic errors, biases that push the SHOES estimate to a larger value. What keeps me awake at night is, what are the systematics that we might not know about when we only do one method, says cosmologist Wendy Friedman from the University of Chicago. Gee, I don't know. Only one method of doing things with one interpretation and one view of exactly how things happened, and all of these massive stacks of assumptions upon assumptions upon assumptions upon assumptions upon assumptions. Gee, how could that go wrong?
Never.
I don't know. Friedman took it upon herself to check distance woes. To measure how fast the universe is expanding right now, scientists need to combine two bits of information: how fast distant objects appear to be receding from us, and how far away they are. The first is relatively easy. Scientists look for a redshift, a stretching of the wavelengths of light emitted by an object. Measuring distance is much trickier. Astronomers employ standard candles, celestial objects that emit a consistent, quantifiable brightness, such as explosions of a supernova variety called Type 1A. So this is actually pretty cool. With a real candle, if an object's brightness is known, we can determine how far away it is by how much it has dimmed due to distance. See, that's the thing. When they come up with with cool shit, and they do. They come up with lots of cool, true, accurate shit.
Right, there are observations.
Yeah, that are observations that are very realistic and very well cross-checked, and it's just mixed so inextricably with crazed bullshit that it's baby in bathwater. And being able to separate the wheat from the chaff, separate the baby from the bathwater of this stuff, is something that they don't even try to do. They either just drink down oceans of bathwater to keep that little baby, or they throw out this gigantic baby because there's a couple of drops of bathwater, and it's just they're constantly doing that. And the truth of the matter is, they have an enormous amount of baby in bathwater that you have to accept is going to be there whenever we're trying to quantify unknown frontiers, and we want to feel like we did it. But the problem is wanting so bad to feel like we did it and feel like it's all done, that we end up coming up with this crazy schizophrenic shit. Man, okay. Setting the distance scale requires a distance ladder, using a nearby object of uniform brightness as a bridge to supernovas farther away. As one rung of that distance ladder, the SHUES team uses stars known as Cepheids. I think that's the right way to pronounce that. Who knows? I haven't Googled it. Which regularly vary in luminosity in a way that allows scientists to estimate their overall brightness. To check the previous supernova results, Friedman threw out that distance ladder. Instead of Cepheids, she and colleagues used stars called red giants, which, at certain stages in their lives, achieve a maximum brightness that is the same for each star. The result is completely different from the ground up, Friedman says. In a well-timed dramatic flourish that rocked the gathering of normally unflappable researchers, Friedman unveiled her team's result in a talk on the second day of the meeting, as well as in a study accepted in the Astrophysical Journal. The result fell squarely in between the conflicting estimates from SHUES and Planck at 69.8 kilometers per second per megaparsec. With a calm firmness, Friedman pushes back on declarations of a crisis, saying that her team's result should cause researchers to pause. So here we have three different ways of coming to similar conclusions, and that really makes it seem as though that they're really onto something, right? I mean, you got these three different ways: the top, the bottom, the middle, and there's just not a whole lot of wiggle room. But the problem is that it's because they're working from similar assumptions, and there are ways that experiments, which are based on empirical data, which is they are observing something out there. They are really, really doing that. That's happening. There's real quantifiable, luminosity and things like that are part of these equations. Okay, so that absolutely is there. So of course they're going to come to some similar numbers. But what we're talking about, and don't be fooled, is what those numbers mean. And that's where we always have this problem of not being able to separate the numbers and their consistency from what the numbers mean. And that is the problem. That's the problem of science. That is the single biggest central problem of science. All right, so holy cow, or H0L little I C, whatever that is. I'm guessing it's some nifty little
acronym or something.
Acronym, right. But even as Friedman's revelation weakened the case for crisis, momentum towards its declaration had already been building. Just a few days before the meeting, the Holy Cow collaboration posted 2 studies of arXiv about a measurement of the Hubble constant based on gravitational lensing of quasars. Bright sources of light powered by a supermassive black hole at the center of the galaxy. 2 studies about the measurement. Okay. Just like a lens, massive objects can bend light's path. The researchers looked at quasars that had been split into multiple images by such gravitational lenses, making one quasar look like 2 or more. The phenomenon is similar to the doubled image of a fish you might see as it swims near the corner of a fish tank. Studying how those quasar images flicker resulted in a Hubble constant of 73.3 kilometers per second per megaparsec, supporting the idea of a crisis. It seems like this is more real after our result, says cosmologist Jeff Chifan Chen at the University of California, Davis. Crucially, the researchers did their work blind, meaning that they hid the answer from themselves until the analysis was finished. This technique can prevent an unintended tendency for analyzers to align their result with previously measured values of the Hubble constant. Despite that blinding, the result was like an echo of the shoes result, Chen says. So here's the thing. If it is instead of expansion that we're measuring, but instead the amount of plasma in the universe, just to give you an example of how this analogy would end up working, where you just simply have the same numbers representing two different realities: expansion versus the content of plasma in the universe. You still come to the same numbers about this particular point. And so what they're actually trying to decide is that quantity that could be either of these two different things. And that quantity is a real quantity measuring something. But the question is, what is that something? And that's what I'm trying to bring to, what I'm trying to highlight, is that there's so many assumptions that can lead to one interpretation or another of experiment. And they're using particular interpretations, of which there are very few that they ever talk about. Meanwhile, astronomer Mark Reed of the Harvard Smithsonian Center for Astrophysics reported a Hubble constant measurement based on megamasers, clouds of gas swirling around a black hole that emit light of a particular wavelength akin to lasers, which, by the way, a lot of times there are arguments about what exactly black holes are. So that's yet another. There are lots and lots of different...
Yeah, I was confused. I was like, are black holes sci-fi? Since when are they real? What is... At the center of every galaxy is a black hole? Like what?
Yeah, a supermassive black hole at the center of every galaxy.
Is that real? I don't know.
I'm
taking it on faith.
It's part of consensus opinion about the observations. We have observed things,
some weird shit
that indicate strong gravitational pull, a lack of light traveling through the center. That makes sense. So that is a black hole, but what exactly is a black hole? That is, there are different ways to explain that phenomenon, which are thought to be there's only one way to, and that's just not correct. And that's where there's always this unified front of physics, this unified theology of science that is bullshit, that we constantly try to believe is there, and that's a big problem. Okay, so also presented were the measurements based on variations in the brightness of a galaxy across the pixels of an image, and other variations of the supernova technique, which use stars called miras instead of Cepheids or red giants. Cepheids? Okay. Meanwhile, another cosmological puzzle is in which, by the way, let me point out right here, this is related to the vacuum energy catastrophe, but it is not an explanation of the vacuum energy catastrophe, by the way. So that's another problem. This is a different problem than the problem I was talking about. So there's just so many various problems in physics where they act like there's zero problems and there's only one viewpoint, when there's lots of viewpoints and tons of problems. Okay, so meanwhile, another cosmological puzzle is increasingly garnering attention, says Hendrik Hindelbrandt of Ruhr University, Bochum in Germany. There are hints of disagreements in measurements of the clumpiness of matter in the universe as measured by a parameter known as sigma 8. To detect this clumpiness, scientists survey the sky looking for a weak variety of gravitational lensing in which galaxies appear to be slightly aligned with each other. This lensing can be used to infer the distribution of mass in the universe, but much like the Hubble constant measurement, that number, as measured by an effort called the kilodegree survey, disagrees with estimates based on cosmic microwave background. So here's the thing. Did you hear where they said infer? Yeah, infer.
Right.
So there are assumptions that there's lots of inferences that they tend to build on, and they just act like an inference is okay, that it's just fine, that that's just part of it, and we shouldn't be really that much worried about all of these levels of inference that they've used all along the way. When in fact, those points at which they're using inference and all of those basis points that they're building on can make the whole theory be rearranged from the bottom up, and can come to completely different conclusions about the entire fucking thing because of all of those weak points. And you come to the same mathematical outcomes with an entirely different theory weaving its way through those all of those experimental results and all those mathematical results that are descriptions of the experiment. And this is just another example of that, where it's you've got the inference of the distribution of mass in the universe from gravitational lensing. Well, there could be alignment. How is it that they know that it's just gravitational lensing versus alignments? There are all of these little judgment calls in their metaphysics that they do not acknowledge are judgment calls. They may be good judgment calls, but they are still judgment calls. And that there's all this developing metaphysics that guides physics that people never talk about or criticize, because the math underneath is this shield that they use. Just because they have numbers, they use that as a shield for the metaphysics. The metaphysics, however, are certainly in fucking question, and the math is not a shield for them. And they've been using it as a shield for over half a century now. Nearly, well, hell, dark matter's over 70, 80 years old now. So they've been using the math as a shield for nearly a goddamn century now. Mm-hmm. And math does not prove the metaphysics. All right. This lensing can be used to infer the distribution of mass in the universe. But like the Hubble constant measurement, that number, as measured by an effort called the kilodegree survey, disagrees with estimates based on the cosmic microwave background. The sigma 8 tension is the second question mark that we have, Hildebrand says. But the discrepancy is not as significant, he notes, and has not been studied as closely. It's not as mature, and it hasn't been in the literature for as long, but also doesn't seem to really go away. And they got this neat little graphic here about early versus late estimates, and
talking about the
estimates of how fast the universe is expanding. So, yeah. All right. So some scientists are wondering if there's any connection between this possible discrepancy and the expansion rate dilemma. If researchers determine that there is a second potential problem with their understanding of the universe, it would strengthen the case that something is wrong altogether. Thank you. They are at least saying that, but there may be something very dramatically, basically fucking wrong with their assumptions at the core. The universe speaks. If the discrepancies can't be chalked up to measurement error, a new theory will be needed that is consistent with all the data. But scientists have struggled to find a cohesive explanation. It's because they don't back up far enough. That's the problem. They never back up very far. They always try to want to back up one tiny little step in their giant fucking linear progression of assumptions. They'll only back up one step because all they need is one step, because all those previous assumptions, those are just fine. They do not do regression analysis very well. They do not continue to regress in their theories far enough to be able to have actual revolution, because they believe that everything that came before has to be right. Otherwise, it would all just fall apart. That's not true. It won't all fall apart. You can go back far enough to completely redo all of your assumptions from a very, very basic level. And that's the problem, is they can't see that forest. They believe that forest can't possibly exist because they see each one of the individual trees, and they understand the trees, but they don't understand the forest. They don't understand the larger overarching theories and their historical context and basis. And that's because, well, you know what? As a specialist, you specialize in one little tiny field, and you don't know about all the ways that you can rearrange these fields together, because you're not somebody who looks at the conjunction of all these various different fields that have so much information in them. That has too much error in it, right? So you don't have specialists for looking at the way the different fields come together. You don't have specialists for looking at how the metaphysics has developed over time. You don't have specialists for that, and so therefore they never regress. They don't think it's possible to regress back very far without obliterating science.
Right. I wonder
That's
if
not true.
I wonder if it's a brain type thing, because like that's the same thing for, and I mean, let's speak broadly, conservative and liberals in the sense of just brain types, because that is a legitimate, real.
Well, it's high risk pattern matching is more liberal, whereas lowered risk accuracy is more conservative.
Right. There are people who self-identify as liberal and conservative, and they do happen to have brain patterns that correlate to one group or the other group, to where you could actually forget telling a man from a woman based on their brain scans. You can tell a conservative from a liberal based on certain responses to certain psychological tests.
Yeah.
Or
well, not just that, brain activation profiles. There's
cognitive responses and things.
Right.
And brain signals and all that. So I don't mean
to,
about,
fMRI.
Right, exactly. I don't want to malign. I don't want to be like, conservatives are our liberals. I'm just saying that there is a genuine divide between those types, and so I wonder if that has something to do with,
and each
with
type
the brain
has
type.
their own weakness.
Just
That's
like men and women, just like everything
else. You
else.
have to be able to understand the strength and the weakness go together, like
for each group,
like a power lifter versus a marathon runner.
Right. So I wonder if it's a brain type thing that, as part of the accuracy seeking and doubt avoidance, that because it seems to be the same thing that doesn't believe in anarchy, or rather is afraid of it. It's like they don't believe that people will be able to just self-organize, or they don't believe that there will. It's this almost like slippery slope thing of like, if you allow this, people will be marrying goats, and it'll just be craziness. It's like, no, that's not. No, you need to allow it to break down some.
Because of the specialization in smaller scale and the increased accuracy that they gain from the specialization in smaller scale things, the larger scale things end up being neglected, and therefore the patterns that can be rearranged at that higher order are not usually very apparent to them. And that is because generalists are typically suck at some of the looking at the details and getting the details right, and so therefore the details are necessary for the larger scale patterns to come together correctly. However, for those small scale individual things to be correct, it relies upon these large scale patterns of what it means and where we're going, and like having an entirely, it's the difference. That large scale pattern is the difference between believing it's the spirit of the fishing tree, because here I am a specialist, I've spent my entire life fishing with this root, and I go and I beat the root and I sing to the god of the tree, and it brings me the fish. I am a specialist in this. I've done it 1,000 times. I know exactly which puddles are too big, which are too small. I know exactly what parts of the tree, where the best ones are that are the most effective and have the most spirit juju in them. There's all of those things, and they don't have the larger scale pattern available to them. Where a person who is locked in that experimental worldview, that tiny little worldview that they have, is actually coming to good conclusions based on the limited information that they have. They are.
Right.
But that's because they have a limit to the
information. But they don't have to have
a
a limited information if we need each other. Is what
but the point is, there's only so much. Yeah, exactly. We need each other. Yeah. There's only so much time a human being
just like
can
men
spend,
and women.
You got to have specialists who spend a tremendous amount of time sussing out these little details, and you got to have generalists who go and take and each one of them corrects the other, and each of them upholds the failures of the other. And that's the point, is we need to be able to recognize each of those types has failures, and that they need the correction of the other. And seeing that there's this back and forth corrective process between generalization and specialization is something that we really haven't recognized that is an important part of it's an important part of developing these systems of information. And so it's an organizational principle that is valuable for so many different things, from governance to looking at the way that you develop an AI. There's a wide variety of looking at this, which is actually part of the Kuhnian cycle. The whole reason why you have to have a period of specialization upon pick something, specialize in it, figure it the fuck out, and then generalize again. And that's what happens. That's why you have death in animals. Animals that have a lifespan that fits the niche period of time that a specialization will be relevant, because you have a changing climate, you have changing environment for that one type of animal, and that's why they have all these different lifespans. Is because and why why is it that they seem to be programmed to die at a certain point? Is because you need a specialization that is relevant for a given period of time. And so basically the specialization period that is valuable for that particular animal is their lifespan. And then you have regeneralization that is adaptive, that goes back to the specialization versus generalization, back and forth search pattern. And that's what it is. It's a search pattern. And so all throughout of our knowledge systems, we need this kind of search pattern occurring. And so we need it in science, of course, to institute a purposeful instead of catastrophic revolution in our knowledge systems. We need purposeful revolution, repeated cycles of generalization and specialization that lead to these continuous revolutions as we try to refine our knowledge of the universe. So anyhow, going back to the universe speaks. How did we get off on the on that interesting topic? I won't call it a tangent because it was fucking relevant. God damn it!
Yeah.
All right.
No, so you were expounding on a point.
Yes. All right. All right. The discrepancies can be chalked up to measurement error. A new theory will be needed that is consistent with all the data. But scientists have struggled to find a cohesive explanation. That's what brought this up. They don't believe a cohesive explanation can happen because they're not capable of digressing, regressing back to earlier theories and being able to reassemble it all from those pieces, because they don't believe that that's possible because they're specialists. Almost any tweak to the universe's history, adding in new types of subatomic particles, for example, would conflict with other measurements, throwing physics into turmoil.
Wow.
Yes, that's why you have to go back further. You have to go back further. We have so many different ways of probing the universe that it's very hard to come up with an elegant theory that passes all the tests without creating new tensions.
Not true.
Well, no, it is true because they keep not going back far enough in the way in which they reconceive physics. Says Dylan Brute of the University of Pennsylvania, because of course, like I said, they just cannot conceive of the possibility of going way back, going back 200 years in our conceptions of what all of that experimentation means, and developing again from that point. How huge is that? That's like trying to redevelop the Windows operating system.
Right.
You know, it's just, there's too many things relying upon it. There's too many companies using it. There's too much infrastructure that depends on it. There's just, you can't do it, man. You can't do it. Actually, that's not necessarily true. So, one potential solution involves the addition to the mysterious dark energy that is causing the universe's expansion to accelerate. An early dark energy.
Oh my god.
Yeah, so we just
add
another fucking piece of aluminum foil on that big old ball of aluminum foil, because that's how we do software development too. You see what they're doing? This is exactly what happens in software development. You do it wrong, and then you keep adding another layer, another fix. It becomes so goddamn unstable. It's just this great big pile of shit. And what you really need is redevelopment from scratch. You have to redevelop from scratch with lessons learned. An early dark energy could have acted in the universe's youth, altering the expansion around the time the cosmic microwave background was released. Poland and colleagues reported at the meeting on June 7th, Physical Review Letters. And disagreement over a Hubble constant has precedent. The estimate has a history of confusing results, says Lucas Macri of Texas A&M University and College Station. In those earlier cases, the universe was trying to tell you that you didn't have the whole picture. In one case, for example, some stars seemed older than the age of the universe. The resolution eventually came in the revelation of the existence of dark energy. After days of discussion, all the evidence has been tallied. The organizers asked for a show of hands. Should the Hubble constant woes be called a tension, a problem, or a crisis? Oh, that's so silly. Cosmologists, it turned out, were a little hesitant to throw out what they thought they knew about the universe. Only a smattering of hands went up for crisis. Arguments that a solution might be found without revamping physics seem to have held sway. Really? I'm so surprised. Still, if the Hubble constant puzzle persists, that could mean the universe is once again trying to speak up. Yeah, it's been screaming out loud all throughout science, if for those who are listening, screaming and screaming that you're failing in multi-pronged ways across a wide variety of the various physical sciences and experimental things, and you keep adding patches to the program. You started with the one gigantic patch that made us swallow the, hey, the dark matter patch. Oh my God, the dark matter was, I don't know how they got that one done. How did they get that one done where it's like, there's 75% of the universe. The greater portion of the universe is just magic fairy dust that you can't detect. It's there though. That is such an obvious violation. People of that time still had some scientific integrity where they wouldn't just allow you to keep adding, crazed, schizophrenic, more and more layers of bullshit, and they'd actually had some level of using some Occam's razor to say, no, we're not going to just add magic fucking fairy dust to our model of reality. And they still had that somewhat at that time. I'm just blown away that they were able to, between 70 and 80 years ago, they were able to have this like, well, the reason our math doesn't add up is because there's magic fairy dust. And now we just believe in the fairy dust really, really hard because the math can't be right. I mean, it can't be wrong. It's,
right. Nice phrase.
It's like, well, okay, maybe it's not maybe the problem isn't that the math isn't wrong. Maybe the fact is what you're observing and what you think you're observing happening are two different things. Right. And that's what they can't get. And that is the problem of science. That's the issue. It's a sociological one. It's a human one. Yeah. It's a problem with humans.
See a mote in someone else's eye.
And yes.
That problem still. And we're very upset about it because we're trying to fix it.
Because there is a revolution going on and it's being suppressed by all these sociological factors. Yeah. There is
not like those
reputable
factors.
Scientists at reputable universities putting out peer-reviewed science and nobody's fucking talking about it. I'm talking about it and I'm the only motherfucker talking about it. even I mean, that's one of the things that on my article that I sent to John Bush is like, you assholes, stop being so fucking so damn humble. Stop it. Nobody's gonna hear you if you're speaking with a quiet voice and not even taking credit for your own original work. I mean, he's still calling it just Pilot Wave and De Broy's work when it's his work to advance De Broy's work in Pilot Wave. It's his, and so he's not even claiming it because he's too. That's the thing. To have the real biasless scientific perspective that gets the fucking job done, a lot of times that requires a person who has so much fucking self-doubt that they won't even credit themselves with what they've really done. And that's what's going on, is that the best of scientists never get heard. And the worst of scientists are the ones that speak up immediately and are heard because they have the confidence that it's required to strongly bring forward a worldview and then here's the thing: people are like, "Oh, well, that's just pop science communication." That's the argument now. Oh, it's just pop science communication. That doesn't mean anything. No, wrong. Okay, where do people? Okay, there is so much specialization in science. No one scientist can review all the evidence and all of the papers just in their specialization alone. It's not fucking possible. They can't do it. So what decides what new information they are exposed to? I'll tell you what does. Pop science communicators. Pop science communicators are guiding and so there's a feedback loop between pop science communicators and what science believes that goes back and forth and reinforces itself. And that's what people fail to and refuse to face, that pop science communication is what drives science, because it also is what drives the public's view of science, and it drives therefore all of the money that is spent on science. And so therefore it is driven by sociological factors that favor those who are more arrogant and those who have more bias over those people who are really self-doubting, who actually do find the truth the best. They are the quietest voice. The loudest voices are the ones that are usually fucking getting it wrong. And it's the quiet whisper that you have to be looking for, of those people who are like, okay, this is what I found, but I don't know, and maybe not, and they'll sit there and I'm sorry, it feels like mealy mouth. I just want to just smack them, but I know it's not their fault. They're doing right. They're being without bias, and the truth of the matter is, it took me 10 years to realize. I mean, there was a point in my life where I realized I had that kind of, self-doubting, self-effacing humility that is ineffectual for very important tasks. And those very important tasks are leading the group towards the right direction requires certain things that have their own disadvantages, which is a type of arrogance, a type of loudness, a type of sticking to one thing, a level of bias. Those things are what actually steer the group. And so there's this terrible decision that has to be made. And that's why I feel like, hey, I can be wrong, okay? Because that's what I'm doing, is science communication. I can be wrong, and I have to be able to deliver something with force and verb on behalf of those quiet voices who are actually doing the real finite, difficult fucking work at those specialization levels. And they're there, and they're just not being heard because there is this culture, this orthodoxy that is reinforced by this feedback loop between pop science and science.
True that.
But by God, the revolution is happening. Revolution is here.
We made sure.
You're damn right.
We're continuing through sending out the signals.
You can't stop the signal, Mal.
Through the CherrySTEM. Something about that signals and STEM. It goes together. Now everybody clap for dark matter.
The magical fairy dust of dark matter.
Yep.
And the woo-woo magic spooky action of Copenhagen interpretation. Or you will be punished. People will jump on you for daring to doubt the orthodoxy. How dare you, you impotent fuel. My entire group will back me up when I say that you're an imbecile. My entire group of the orthodoxy community. You're an imbecile for daring to be a heretic like that.
You apostate.
You apostate. The amount of vicious attack that you can just go out and try it. Go out and doubt something. Just ask a question. Respectfully ask a question. Now, it's not nearly what it was just 10 years ago. But about 10 years ago, it was crazy. It has literally been almost 180-degree turnaround. It's been an enormous fucking change in the open-mindedness of the physics community, as well as because of the changes in the popular community, because they're happening at the same time. When it comes to people asking questions, I was literally, by simply asking a question, and in a very, very respectful and humble tone about relativistic physics, I was banned immediately banned from a physics community. It was an online, like a very popular online forum back like 10 years ago. And we're not talking about a history of me being some sort of rebel rouser or anything. We're talking about I was trying to make sure to fit in. I was doing my damnedest to fit in with the group there of being the humble. Oh, please, I am below you. Please educate me. I couldn't possibly understand anything, for I am a lowly nothing who could never understand the magical wonderfulness of God. I mean, of physics. And so please educate me. And they still fucking banned me for asking the wrong question.
Wow.
And it was
Reminds
just
me of feminism.
Oh yeah, and they would attack viciously in groups every time anybody dared to question the orthodoxy in any way whatsoever. Doesn't matter how many references. Doesn't matter if you're doing it in a in a forceless way. As a matter of fact, they'd attack you more if you presented it in terms that were more equivocal, that you weren't sure and you just wanted to know, and then you get attacked even more. And sometimes if you were just self-effacing enough and put yourself on the bottom and really prostrated yourself before the almighty power of the consensus, then they might laugh off that your ignorance, that you somehow got misinformed by some of those crazed whack jobs who dare to ever doubt the consensus. And so it's just such a familiar tone of zealotry. That's I see what you're doing. That I've experienced before in other places, but then that has actually changed quite a lot. But you could still go out right now, find the right community, and just start asking the wrong questions about physics, and you'll get attacked. It'll happen, and you can try this out yourself, and you'll see it's you'll get attacked and basically ridiculed. Though there will be someone who's still going by that old methodology of just attack the heretic. Right. And it's still there. It's definitely not gone at all. There's still not an honest, open examination and self-examination of things and saying, hey, what about this evidence? What about this evidence? What about this evidence? That is still it's still not allowed. It's still, there's a tremendous amount of pushback. It's just not quite as bad. Well, it's not nearly as bad as it was just a little over a decade ago. And I'm really feeling good about the changes, even though it's still not where it's supposed to be. It's still not.
Still annoying.
There's still not the level of self-doubt and self-examination required, even with all of these ways that physics is going wrong and that people know that it's gone wrong in a million different places in a million different ways and in gigantic amounts. They still will have these people will put on speeches about how perfect physics is and how we're just off by these tiny amounts, even when that is demonstrably and exactly specifically not correct, period. And they'll still talk about how it's just, we just got the little tiny things to figure out, and that's it. It's not a big problem. We're all in agreement. They still have these kinds of speeches of unity that are just entirely bullshit. And so there is still a huge problem present, but there is the shifting of the ground that is happening. That you can see in science communication, in various in the numbers, the sheer numbers of published articles, of published material, which are looking at alternative explanations for our experimental record. That has increased. It's exponential how much that's increased in just the past decade. So there's really a lot of positive. There's a lot to look forward to. There's a lot of changes happening, and I can totally see the ground continuing to shift tremendously in the next decade.
Yeah.
So that's it for me. I'm done with my spiel.
I think that's it for us then.
All right.
That's all the spiel we have.
We spieled all we can spiel. We can't spiel no more.
That was the last that we had to spiel.
I'm feeling a little verklempt.
Well.
Oh, and now I'm about to get back to. Oh man. So I'm just going to briefly mention for anybody who is in the after show, etc. I'm working on some fiction that is going to be so much fun. Basically. Those of you who may have seen any of my other work is that I try to use edutainment because that's really the best way to educate people about things that are kind of difficult, like the history of physics and all of that. Man, a lot of times getting people to, I may be obsessively, digging through all of the old English and all of the various publications and reading them, but even the people who are really into Maxwell's equations never read Maxwell's actual papers, and so there's just getting people interested in the history of physics and stuff like that's really difficult. So I rely on edutainment, and sci-fi is a really great way to go. So I am about to send off some interesting sci-fi stuff set in the 30s, which is Weimar Republic, Germany, just before World War II. where you had the Thule Society and the all of these various esoteric groups all doing these weird things. And so I'm going to tie it into alternative views of physics. And of course, there's still going to be magic and and all that silly shit. But the point is to get across some of the picture of the history that led us to where we're at, some of the sociology, some of the real events, and because I'm weaving together a tremendous amount of the real history of Germany's research into various ideas and that actually did kind of lead to like 19th century physics and I'm putting all that kind of together into a sci-fi setting for a role-playing game. And having talked to one of the developers of the role-playing game, I think I have a good chance of them reading it and loving it. And it's just a real fun, fight the Nazis. Well, they've already got a setting that is basically kind of a fight the you could be what's his name, Indiana Jones. Do the Indiana Jones thing, and and that sort of, and they have these special, psionicists and fun stuff like that. Well, I can weave together all these various concepts and use it to tell the story of the Weimar Republic and all of their esoteric stuff as a way to kind of relate some of the history of physics. And so that's just a fun little thing I wanted to share with you guys, that once it's if it kicks off, you'll have heard about it here first. But it's going to be instead of just Indiana Jones, and you're also going to have the Nazis of Indiana Jones, except the pre-Nazis, the Thule Society, and they're one of the central figures that I'm relying on. So lots of fun to be had there, and I hope that some of you are interested in explorations of the imagination, like role-playing games, and we'll check that out if it ever does come to fruition. I will keep everyone posted, because that's just a lot of fun.
Mm-hmm. Heck yeah.
Oh no, I spieled again.
Oh no.
I spieled it all over the place.
I thought we didn't have any more spiel.
Can you clean up the spiel?
We did. We had more spiel. I will clean up the spiel.
Thank you. Is it with a papier towel?
I just got it. Okay. Yeah.
Paper towels
There's
made of
some
academic
paper towels
papers.
and some mops for the spiel.
For the spiel. We use academic paper towels.
Definitely.
To clean up our spiel.
Can't handle anymore.
Oh, I know. I'm sorry. That's not very funny, is it? I have to excuse
too funny.
it. I'm sorry.
Never apologize for who you are, baby.
All right.
Okay.
We love you guys.
Yeah, we do. Thanks for putting up with this. We're gonna go spiel some more of this on our patrons. I may or may not have an article we're gonna be discussing. We may just read shit. I don't know.
Mages? What?
Yes. All right. We shall see you all Monday after next, because we will be coming at you every other Monday. So if you want to make them more frequently, there's a Patreon. Did you know?
You'll end up hearing about like cool things about sci-fi and other fun weird shit
On Patreon?
Sure.
Yeah. I mean, definitely. On Discord anyway. We're 57% of the way to more episodes. And so let's do that. We'll do CherrySTEM every week, and then I'll give you interviews and stuff. So, yeah.
Yeah.
Help me out. Help a brother out. So the uncommon tier is what you might want if you want to hang out in the after show, and here is our milestone, and you get access to 300 exclusive posts.
And Nazi UFOs! Wait, no, never mind.
Definitely not. You will not find
You will not find.
Nazi UFOs in this Patreon.
Yes.
Now we're off to Discord to hang out with patrons. And we'll see y'all Monday after next. And hopefully we'll have prepared a love and fear talk in time for Valentine's Day, since we've been wanting to do it for like 2 months. It's probably a good time. It'll be fun. It'll be a fun time. Come hang out with us Monday after next. You should probably just follow the channel. So
Were you recording?
that way you get notified. YouTube records.
Oh.
Yeah. I just got paranoid
Wait,
about
was
absolutely
there-
everything.
was
I was
there-
like, were we streaming?
I know, me too. Were there comments?
Yes.
Okay, good.
We're good. We're good.
I know, because that's how I have gone on for an hour or two. Was it 2
It
hours?
was like an hour and a half.
An hour
almost.
or 2 hours?
It's like an hour, yeah.
Oh God. Okay, I'm gonna say it's 2 hours, even though it was probably an hour or an hour and a half. But it was. I went on for 2 hours where it wasn't fucking recording my time. She was like, oh God,
I'm sorry.
it's horrible.
I'm so
I'm
sorry.
still suffering. I wake
know.
up in the night, the sweat,
Remembering that.
remembering that time.
I'm sorry. That was a lot of trauma.
It was.
Now let's go visit some more trauma on our patrons. Discord. Alright, guys. We'll see you soon on this channel, and there'll be other things on this channel other than CherrySTEMs, I promise. I swear.
Swear to God.
Though we do have a second channel with Ironies, Angels, behind the scenes stuff, so that's gonna be on there. And yep. But I'll still try to post Patreon sets stuff on here. So see you whenever I see you. Don't join the Discord. That's where we're at every day. If you're missing our faces, come fucking hang out and come become a patron, because it's a fun time. Okay. See you later. Good night, everybody.
Meow. Kitty says.
Good night.
Good night.